Bar Technologies is a wonderful organisation that we're a spin-off from an America's Cup design team, and in exactly the same way as most, if not all, of the Formula One teams have a technology arm that leverages their skills, their tool sets, their expertise from motor racing and takes them to industry. Bar Technologies was the very first organisation to do the same, but in the maritime world.
The whole basis of Bar Technologies is using the suite of software and simulation tools that we have available to innovate and really push boundaries of design away from the conventional and the tried and tested. The design team here really relies on the NX and Simcenter software tools on a daily basis to really keep pushing those boundaries of our design, making optimization loops, reducing weight, reducing cost, and designing for manufacture.
Everything that we do here is targeted to help the maritime world decarbonize. It goes from the wind systems, propulsion systems for vessels, down to the foiling systems for smaller boats. It's all about making them more efficient, consume less fuel, go further on a single battery charge, all about making the maritime world less polluting and a more environmentally friendly industry. WindWings, the system that allows ships to use the wind in a way that we're used to, but in a modern way. All the foiling systems that the team design and develop, which allow vessels to come out of the water and become more efficient. They're just two of the many products that the team have developed.
Working in green technology is really bringing in a lot of new talent, a lot of new youth, and that includes female engineers who perhaps traditionally weren't appealed to the greasy traditional industry of engineering and engines, but are looking for innovation and pushing boundaries with a climate focus.
I focus mainly on the WindWings, and those are hydraulically powered. So we, as the hydraulics team, use Simcenter to model what's actually going on in those wings, how they're actuated, how they're moving, everything that's going on. So all of the data that we use from Simcenter helps us understand the behavior of our product.
Yeah, so you can see on my screen I've got the 24-metre WindWing open. So I've used various CAD packages before at university and things like that, but it's my first time using NX for the job. We've got Simcenter, we've got drafting, obviously the CAD modelling itself, all under the Teamcenter umbrella. We
can take the detailed CAD modelling, and when we make updates to that, it can feed through immediately to the Simcenter world and to the finite element analysis. And that allows us to have really efficient design loops where we can modify and optimise the design and very quickly see the impact of that.
So by using NX shipbuilding, we're able to model the bits of hull that we need. So we don't need to model a full vessel, but just those frames that are important to us, and then we're able to put our normal CAD of what we've modelled for our wing, and we're able to put that on top of the vessel and then conduct analysis on that to make sure that the wing is safe and the vessel is safe throughout all our operational loads. We have so many design inputs from whether that's for NX shipbuilding, we have the hull plans from clients, they need to live in Teamcenter, so we can open in one part, we open the hull model, we can see everything that's gone into constructing it, the loads that we need to apply to it.
That we have to be able to turn design ideas into reality very quickly, more quickly than before. We have to be able to optimize very quickly, more quickly than before. We have to be able to react to changes in our products, either due to new innovations that have come from within or due to external factors, very quickly, much quickly than before. So all of that is being solved by and aided by generative design and AI, and like others, we are absolutely embracing that.
We use lots of parameterization in STAR, and this really allows us to run maybe 200, 300, 400 simulations at a time on variations of a wing, variations of a hull, and this allows us to get a huge data set of results, which we can then feed into our in-house neural networks, AI surrogate models, and we can then quickly interrogate those and optimize our designs.
We're really seeing our products take off, the market is ready for them and open to these new innovations. Climate change and the impact it's having is creating a drive for it, and also a receptive market to receive these innovations. The tool set we have here allows us to keep innovating, keep developing. There are always new products and new ideas coming out from the team.
We're working on a product which is ultimately saving fuel, and for WindWings is saving up to 1.5, or on average 1.5 tonnes of fuel per day, and that's really inspiring. To sit here thinking that I can actively make a difference. And I'm a passionate sailor as well, and I love that I can use my hobby and my engineering and my love of engineering and combine those and do a bit of good in the world.